Hello and welcome to the C programming lecture on if-else statements, also known as selection. What is the purpose of selection in programming? Selection can be thought of as making a decision or going down one of several different paths. In computer science, this concept is also known as branching. The basic concept of branching is to instruct the computer to begin execution of a different segment of the current executing process or program. So basically it allows you to execute either segment A or B of your program. So for our particular use case, we're going to be looking at the if statement. In C, the if statement allows us to branch our code in various different execution paths. The if statement requires parentheses around a Boolean expression, which we learned about. It will execute either a single line or an entire declared block of code, which we use the curly braces for. And the basic structure here is we have an if with our Boolean expression wrapped inside parentheses. Here's an example of a Boolean expression. And we can either terminate that with a semicolon, or we can have curly braces to create a new block of code. The semicolon would be at the end of the if statement, followed by one other function call or some other type of code. So here are some examples. Here we have two variables, x and y. We're printing out x and y, and we're printing out the beginning of the program. We can see here's our output. Now our first Boolean expression is checking whether or not x is greater than y, and we can see here x is 10 and y is 5, so this is true, and this is all on the same line here. So since this is on the same line, we can see that the if statement terminates here, so what we should see is that this statement is printed out, and then this following statement is then printed as well. So just double checking here, we see check 1. The expression, our Boolean expression, we see it here is true, and then we see check 1 again out of the if statement. Exactly what we expected. So the next line we can see gets a little bit more confusing. Just like I said, we only can have if we do not have curly braces like down here, we only can have a semicolon terminating the single line. So we can see that this statement is false because it is the inverse of our first statement. X is not less than y. So this should not print out since this expression is false. And we can see that here, that check 2 only prints out of the if statement right here. And you can see that indentation does not matter. Even though we indented this, it still printed this line out. So do not get confused. This was done just for that particular purpose, to show you exactly what would occur even if you indented it. Now, here we go again with the check 3 and scoping. We can see that it prints out inside the if statement, and inversely we can see we're basically doing the same checks as above, but we are just creating a scope using the curly braces. And you can see check 4 is the same one as our check 2, and it should not print anything inside the function, but it should print the end of our program here. And you can see that here in our output we have no check 4 listed. Okay, so the if statement also has its partner, the else statement. So basically you can combine logic and have something like, if this occurs, execute this block of code, else execute this block of code. Now, if you can imagine, you can either have segmented code that is in blocks of just repetitive if statements, or you can just, if it's one of two conditions, you can do if this occurs, else this happens. Something along those lines, really. So here are some examples of this. Again, we're sticking with our x equals 10 example, y equals 5. We're printing out those values. And again, we're using the same scope. The else statement here also can use curly braces, or just like the prior, you can have it terminate on one single line. But I typically find it to be easier to read when you have these curly braces in, even if it's just one line of code. So we can see here that our first statement should be true So 10, which is x, should be greater than 5, which is y. So what we should see is this first line 14 print out. We see program again, and then we see this is true. We should not see this else block should not execute, which we do not see. And again, we inverse the statement here, and this statement here in the if statement should not be executed, but our else block should be executed. And we do see that happening here. This is on line 26, and we can see the output here right before the end of the program. So the if statement and the else statement are one block that you can create. There's also a combination that you can use called the if else. So basically it's an additional check. So you can create things that are multi-branching. So you can do things like, if the color is red, do this. Else, if the color is green, do that. Something along those lines to create some type of complex branching logic. And to put this into other words, we can have several paths to execute down and choose one of those paths. So here again is another example of this. What we're doing, instead of just having one else statement, is we have an else if statement. So we're checking to see if x is, well, first we assign x to 21. We print out some information. We're beginning the program by checking to see if x is greater than 50. And if it is, we print this out, but it's not. So we go ahead and check our next statement, which we say, okay, is x greater than 25? If it is, print this out. No, it's not. Else, we're saying we're printing out x is greater than 20. So we're ending the program here. So technically, this could just mean we could print out something a little bit different here, but we know that for our use case, this works. And I hope this draws a pretty good path in your head of how this works. So again, to just kind of recap things, Booleans or bools are true and false values, and we can create Boolean expressions by doing things like, is this value less than or equal to that value, which we call Boolean expressions. The if statement allows us to do a selection or branch our program. So we can hop between different segments of the code depending on what our Boolean statements evaluate to and how we use these to jump between different execution paths. The if statement can be combined with else statements in order to create complex branching logic, just like we saw previously. And if you can imagine, you can nest these pretty deeply. That's kind of a controversial topic, but however the logic unfolds in your mind is usually best how you should just type it out and figure out how it works and how you think it best kind of flows. So that's kind of a nice recap of what we just went over. So why don't you take some time here and let's do a little exercise. I want you to create a program that will print out whether or not a number is even. So first things first, just write a program that tells you in standard out inside of our console terminal whether or not a number is even. Next, I want you to take that same program and I want you to kind of build upon that. I want you to create a program that checks to see if a number is evenly divisible by the number 3. And I want you to print out the word fizz. And if the number is evenly divisible by the number 5, I want you to print out the word buzz. Now, if it's the number that you have is both divisible by 3 and 5, I want you to print out the word fizzbuzz. So if none of these are the case, just default to print out whether or not the number's odd or even. So again, this is just an exercise for you to do. We can do this inside of the code segment just to give you kind of a review of how I would do it. There's no right or wrong answer here. You're just trying to build some skills. So don't feel uncomfortable if you get some of the stuff wrong, and make sure you follow along with me if you struggled through this. Okay, welcome back to the programming session on if and else statements, or also known as selection statements. So at the end of the video, we had an exercise that we needed to do. So let's go ahead and just start out with that. So first things first, always like I do, I'm going to go ahead and create a file, main.c. I'm going to go ahead and open up that in our editor, and I'm just going to go ahead and write our standard program here, which is just our hello world program. And now I tried, just like I say this in pretty much every video, I try to make this a habit of doing, because it just makes me make sure all my tools and everything's working properly. So you can see that here's our standard program, our hello world program. I went ahead and just wrote all this stuff here, and I compiled it using GCC, and I just executed it just like our other videos. All right, great. So now we know that everything's working, our tooling's working, our editor's working. Let's go ahead and just assign a variable. Let's just make an integer variable. Let's call it the number. Let's just make it a nice even number 2 for now. So our first program that we needed to do was we needed to write a program that prints out whether or not a number is even. So how would we do that? Let's think about it. So if we knew that a number was even, what would be, I guess, what would be the easiest way to tell whether or not a number is even? So if you can think back to some of the code that we went over, some of the things that we went over, it turns out the modulus operator is really good at being able to answer this. So if you think about it, if any number is even, it should return a remainder of 0 when it's divided by 2, right? So that is not inclusive of the number 0. So we'll just go ahead and say that's the base case for now. We're going to not include any 0 value for now. So let's just go ahead and do this. Let's just write a simple if statement. We'll just go ahead and just get our little shell set up here, and we'll go ahead and say if x modulus 2. Now this is going to be 0, right? So if we were to, for instance, include std bool.h, and we took this expression out, right? And we said, let's say bool, let's just call it b. If we took this expression out, it's going to tell us, it's either going to give us a non-zero value or 0 value, right? So if it's non-zero, it's going to be considered true. If it's 0, it will be considered false. So when you think about it, if we want this block of code to execute, then we need to check whether or not the output is 0. So I'm going to go ahead and erase this because I like to write it like this instead. So in parentheses, I'm going to make sure that this is equal to 0. This means basically that x is divisible by 2. And what we're going to go ahead and say here is we're going to say x is even. Just like that. So let's recompile our program. We forgot our semicolon. Let's make sure we add that and recompile the program here. GCC main.c, make that out. And there we go. X is even. So let's just try adding another number that we know is even. Let's just say 256. GCC main.c, get that out, and x is even. Perfect. Now let's just try a odd number. All right. So GCC main.c, out, nothing prints. So what can we do to say whether or not a number is odd? So we can just simply add an else block, right? And we can just put our print statement here, and we can say x is odd, like this. So GCC main.c, out, x is odd, right? Makes sense. Okay, so from here, what we can do now is we can move on to our second portion. So our next portion of our program wants us to be able to tell whether or not a number is evenly divisible by 3 or 5. And depending on whether or not it is divisible by 3 or 5, or 3 and 5 as well, we need to have different outputs. So let's go ahead and just think about this. So our first case is whether or not a number is evenly divisible by 3. So we can pretty much use the same code here, right? So we can write something like this. if x is divisible by 3, evenly divisible by 3, let's print out the word, let's see, fizz. Make sure we have a new line there. And let's see our next case. So let's just do them one by one, right? So if this is the case, we want to see if it's evenly divisible by 5. And we'll kind of rework some of this logic so that way it runs a little bit smoother. And if it's evenly divisible by 5, we want this to print out buzz. Now the next case is if they're both evenly divisible. So like, let's say for instance, the number 15 is divisible by both 3 and 5. Matter of fact, let's make that our use case, 15. So let's start here. If x is divisible by 5, and we want it to be in one line, right? So is equal to 0, right? Same exact thing as here. Now, what else can we do? Now, we can say we can actually nest this one inside of here, right? So we can do something like this. If it's evenly divisible by 5 and it's evenly divisible by 3, then print out this, right? So let's see this. So if it's evenly divisible by 5, let's say printf fizz. And then if it's evenly divisible by 3, printf buzz, right? So we can say, we can actually reverse these if we wanted to. Doesn't really matter, whatever you're more comfortable with, but because I wrote fizz first, do this, fizz, and then buzz, right? Something like this. So we know, logically speaking, that when we hit this block, we should have been at least divisible by 3. But that's a repeat of this one. So we don't want to repeat, all right? So what we'll do is we'll delete this one. We'll move this one down for the time being. And then we'll just think about this a little bit longer. Okay. So we know that the value 15 is divisible by 3. It's going to be, this is going to evaluate to true, this Boolean expression. So this will be printed, our fizz. Now next what will happen is we're going to go ahead and ask whether or not that same number is divisible by 5. And if it is, we're going to print out the word buzz. Else, we don't do anything. But what we could do is we could say else here, and we can just simply print a new line. That way we don't have to worry about that case. So this is our basic check, right? So basically what we're saying here, and this is very important, if x mod 3 is equal to 0 and x mod 5 is equal to 0, print fizz buzz. Else, if x is mod 3 equal to 0, if that's the only thing that's true in this whole block, only print fizz and then a new line. So we've kind of covered our bases here because we split these two up. So what we should see is, in this case, this should be executing properly. Now what would happen with 15? Think about this. So 15, this would execute, this would be true, this would print, this statement here would print out to our terminal. And then here, this would print out buzz with a new line. Now we end up here inside of our code and we actually print back out the word buzz. So this is not correct yet. What we need to do instead is actually add an else statement here. So again, this logic is a bit confusing and there is ways to do this with other steps, but this in particular makes it a bit easier with our current knowledge set. Now it's very important that you remember that I say the word and, because we're going to be coming up to our other logical operators, which are and, or, XOR, all of these other things that we're going to be using to construct more complicated statements. So, okay, so this should cover our basis for our fizzbuzz, but now let's somehow work that in. So we're saying we have our first base case done here, and this checks to see if it's divisible by 3, prints out fizz. This checks to see if it's both divisible by 3 and 5. It will print out fizzbuzz, else it will just print us a new line. And then here's our else block in case this first one fails. So for instance, 10 should only print out buzz. But in the case of a number like 1, we want to print out whether or not something is even. So we can just take this entire block of code we wrote before, and at the very end, we add another else statement to this end, and we have our base statement, which just basically tells us whether or not x is even or odd. So let's go ahead and try to compile this program. We have a compilation error, and that's because we forgot our semicolon here. So let's go ahead and add that. Recompile, add, and we can see that we get exactly the result that we expected for the value 15, which is fizz buzz. Now let's try another value. Let's try exactly what I said, which is 10. And what do we expect in 10? We should only see buzz. So GCC may not see, a.out, buzz. Exactly. So again, let's try the value 1. GCC may not see, a.out. And yes, that's exactly what we should see. And again, I can keep replacing things here too. We should see x is even. GCC may not see, a.out. X is even. Exactly. So just to give it one more shot, let's use the number 30, right? So number 30 should be divisible by both 5 and 3. So we should see fizzbuzz. GCC may not see, a.out. Fizzbuzz. Yep. So let's think of another number real quick. Let's just see if fizz works. And a number we can choose for that would be 6. So GCC may not see, a.out, fizz. And there we go. Of course, there is a space here, which, you're not technically supposed to have for our output, but that's all right. We don't really have to worry about that too much. It doesn't really hurt. Matter of fact, we could just place it here, and we could remove it here, and no harm, no foul. So it doesn't really matter how you want to accomplish this at a high level. This does exactly what we were supposed to do. And again, we can add other logical constructs that we'll learn about, which are and or statements or things of those natures that will make these operations a little bit easier. And a matter of fact, this even or odd thing when it comes to integers is even more easy than using the modulus. We could actually just check the last bit inside of our bits, right? So in all of our first bit is basically an indicator whether or not something's even or odd. So anyways, that's besides the point. Hopefully you guys enjoyed this video and followed along with me pretty well. Hope you enjoyed solving this kind of a weird problem. And this is also known as fizzbuzz. Sometimes this will be asked inside of an entry-level coding interview, so it's kind of good to just familiarize yourself with how to use some of these things that we were learning about. Anyways, see you guys in the next video. Thanks for watching.